Yesterday I gave you an assignment to come up with a conditional statement, right? And I asked you to make it. I asked you to make two conditional statements. One of them that was true for all cases. So I wanted the conditional statement to be true. I wanted the converse to be true. We wanted the inverse to be true. And we wanted the contrapositive to be true. And you didn't have much trouble with that, did you? Okay? You all were able to come up with that one fine. But I asked you another one. I asked you to come up with one where the conditional statement was false, and then the converse and inverse were true, and then the contrapositive was false. And let me just ask you about this. When you were doing this, were you thinking, okay, here's my statement, and then you made sure it was false, and then you thought about the converse, made sure it was true, then you thought about the inverse, okay, you said that one to yourself, wrote it out, okay, that one's definitely true, and then you thought about the converse very carefully, made sure it was false? Is that how you did it? Because if you did way more work than you needed to do. What were you saying, Gavin?
The last one took me like 30 minutes.
Did it? Yeah.
The first one was kind of hard for me.
Was it?
Yeah. I did that, like the last one first.
Okay. But what did I tell you guys about the truth values yesterday? What was it?
The top one and the bottom one are always going to...
So the conditional statement and the contrapositive will always have the same truth value.
And then so is inside.
Right, and the converse and the inverse will always have the same truth value.
So we really only had to figure out the first and the second one?
Exactly. So if you know that the conditional statement is false, and you know its converse is true, then you already know that the inverse will be true and the contrapositive will be false. Because these two will always have the original statement and its contrapositive. They say the same thing. So if you don't clean your room, then you're not going to the movies with your friends. Let's say that's a true statement. Okay? So now let's do the contrapositive of that. If you do go to the movies with your friends, then you did clean your room. Notice on the negation I had to take the not out of that one, right? But do you notice that those statements, they say the same thing, don't they? Okay? So, did anybody come up with one that works here? What do you got?
I did, I'm pretty sure this is right, but if you're an animal, you're a mammal.
Okay, if you're an animal, then you're a mammal. That's false. Okay? So if animal, then mammal, I'll just abbreviate it like that. Definitely false. Because can you think of a counterexample? Sure, there's lots of counterexamples, aren't there? But if we think about now the converse, if you're a mammal, then you're an animal. That one's definitely true, isn't it? Okay, so will the inverse be true? If you're not an animal, then you're not a mammal. True. A mammal. A mammal. The contrapositive. If you're not a mammal, then you're not an animal. That's true. So all we have to worry about is making sure the original statement's false and its converse is true, and then we know the other two things are going to work out. Who's got another one? Yep. Farley?
If you lay eggs, then you are a hen.
If you lay eggs, then you are a hen. And you're saying that's false? Yeah, but don't turtles lay eggs?
Frogs lay eggs.
Yeah, frogs lay eggs. Insects lay eggs.
Dinosaurs.
Okay. Now, we can go on forever, but how many counterexamples do we need? One. Okay. So, the converse of that would be, if you're a hen, then you lay eggs. Which is, okay, we'll say that's true. And so we know the inverse will be true, and we know the contrapositive will be false. Contrapositive. Okay. So, one of the things we didn't have time to talk about yesterday that I wanted to discuss with you, if you'll turn to page 69. Okay, a biconditional statement is the one thing we didn't get to cover yesterday, and the notation looks like this: P, and then you have the arrow going both directions, and then Q. And here's how a biconditional statement works. If a if-then statement is true, the conditional statement is true, and its converse is true. Let's go back to this. If the statement's true and the converse is true, what do you know about the inverse and the contrapositive?
They're both true.
They're both true. It's all true. Okay? So if we know that both these are true, then the statement can be written as a biconditional statement. And in a biconditional statement, you state the hypothesis, then you say if and only if, and then you state the conclusion. So it would be something like this. Let's think about this one. If two lines in a plane, in the same plane, intersect to form a right angle, then they are perpendicular. True? You can at least shake your heads. Is that true or what? Two lines in a plane intersect and form a right angle, then they are perpendicular. Is that true? Okay. Let's think about the converse of that statement now. So if two lines in a plane intersect and they are perpendicular, then what type of angle do they form? They form a right angle, don't they? So is the converse also true? Okay. So if that is the case, then we can make this a biconditional statement. And we can say two lines are perpendicular if and only if they intersect to form a right angle. Or I suppose we could say four right angles, couldn't we? That's how a biconditional works. And it doesn't matter which one is the hypothesis and which one is the conclusion. So if we want to say if two lines in a plane intersect to form a right angle if and only if they are perpendicular. That's how a biconditional works. Let's look down on the bottom of page 69, number 10. Do you see it on monitoring progress? If an angle, right there underneath number 10, it says, rewrite the definition of a right angle as a single biconditional statement. So definition is, if an angle is a right angle, then its measure is 90 degrees. I don't think you guys understand what a single biconditional statement is. It means like this, if and only if. So let's just look at this statement. If an angle is a right angle, then its measure is 90 degrees. Is that true? Okay. If a measure of an angle is 90 degrees, then it is a right angle. Is that true? Okay. So that means that the original statement and the converse are both true, which also means what? Blake, what else does that mean? Exactly. It means that the inverse is true, and it means the contrapositive is true, right? So if the original statement and the converse are both true, that means all the statements are true, and it can be written as a biconditional statement. So you could say an angle is a right angle if and only if its measure is 90 degrees. Okay, so the original statement and the converse both have to be true, and then you can write the statement as a biconditional statement. Let's look at number 11. If two line segments have the same length then they are congruent segments. Is that true? Okay. If two segments are congruent, then they have the same length. Their measures are the same. Is that true? Okay, so the original statement and the converse are both true. So we can write that as a biconditional statement. We can say, two lines, now notice I don't say if, do I? Two lines are congruent. Here, everybody say that with me. If and only if they have the same measure. Or you could say two lines have the same measure if and only if they are congruent. It doesn't matter which one comes first. Okay? See the two direction thing here? Goes either way. Now everybody look at number 12. If Mary is in theater class, then she will be in the fall play. If Mary is in the fall play, then she must be taking theater class. Is one of those statements the converse of the other statement? It is, isn't it? Okay? So let's assume that the first one is true. If you're in theater class, then you're going to be in the fall play. That's part of the deal. And if you're in the fall play, then you're taking theater class. Now each of you think about that biconditional statement. You got it in your mind? Okay? Tell it to me.
You are in the fall play if and only if you take theater class.
There you go. You're in the fall play if and only if you take theater class. See how that works? What has to be true before you can write it as a biconditional statement?
Both of them have to be true.
The original statement and the converse have to be true. Which, by the way, don't forget means everything's true, right? The inverse and the contrapositive are true as well. Okay? All right. I actually made an Alex assignment for you for this.